Yeah, no, this is Daniel. We're going to be talking about bench supply and the multimeter assignment. So first of all, let's show you the checklist what we're going to achieve. Or first of all, I'm going to write my name, obviously. Just write my name there.
Have a look at this.
Okay. And then note the expected resistance of 3 different resistors used for different color codes. So we got, I've already pre-wrote these down. So we got red, brown, red, brown, brown, red, black, brown, red, brown. Got the ohms right down here. Let's see. These all here. And I got the values all there. Use the resistor ones here to get the numbers. I'm gonna take that off.
All the dots along the black line are connected together, and all the dots along the red line.
Okay, what are we talking about? Measure the resistance of 3 different values using the labs multimeter. So obviously, here's the multimeter I'm going to be using. I plugged it in. We're going to start with this resistor, brown, red, brown. So I'm going to see if I get here quickly. So obviously, press the operate and press ohms, and I got 117.86. Let's write this down.
That's how it looks physically.
Brown, red, brown.
And there's a little edge on it there.
117.84.
On the edge there.
17.84. I need to get the tolerance.
What do you see there? There's 1, 2, 3. 3 of these connections are fine. The lights are on. These 2 are on.
84.
This would end up being 10.
Minus 5.819. Minus 5.819. So 111.948. That's what the tolerance.
They're just separate.
So that's gonna be 111.
What I could do later on is I could do something like this. So
4,
because I can see what you can see
8.
now. So just ignore it. Why is that not working?
Okay, 1 second.
Yeah. Through the LED.
I'm gonna get the upper resistor.
Yeah. And then across the gap. See the way we connect together across the gap? And into the resistor, over the ground. So there's a loop here. Does that make sense?
It's not really it's just kind of like, it's the same kind of loop, but like the loop also goes down here as well.
It's a parallel loop. It's a parallel loop, okay? So this one
And then put it down the second resistor. So operate ohms. Get 11.86 for brown, red, black.
then down to this.
Get 11.84. And then also we need to get the tolerance 1.84.
But from a different angle.
0.512.
And the negative terminals. So the
0.512.
blue wire, they get across the gap.
We've already begun. That's going to be not under
Minus
respective resistances. Resistors would have
2.
Why is this one not working?
11.248. 11.248. And now we're gonna get the last resistor.
I haven't seen you before, have I?
Yesterday.
You were here yesterday?
Yeah.
Go ahead there, grab your. If you're in Group B, just don't worry about the list. You're a bit late joining, aren't you?
Yeah.
No, but what happened last week?
Last week,
Were you here last week?
I was in the Group A class for this last week.
Okay, now onto the last resistor. The last resistor is red, brown. So operate.
The reason this isn't working, right?
217. Alright.
Connected to the negative terminal.
217.70. So we get the tolerance of that. 217.70.
This one,
10.8.
So it's not that it's what we mean by it's when the circuit is closed, the connection.
So 206.845. 206.845. And that right there is the measure resistance use a multimeter. Like, alright. Okay, now we're going to be drawing a circuit schematic showing DC voltage supply connected across two resistors connected in series. Choose supply voltage, volts. Okay, so let me just draw a schematic
And
quickly.
then you don't have to be sorry. Just absorb what I'm saying. No apologies. I just want to make a breakthrough with you on the point.
Okay.
So it's the same thing. Don't be anxious about this reading. People make these mistakes all the time. We're just trying to figure out how to find a pen. Just draw these connections. This connection here, here to there. Simply backwards.
Out there. We're going to put this one as 220 ohms. It's at 12 ohms, and it's at 120 ohms. And then volts, I want to do 6 volts. So we're going to add all the resistors up, so 120 plus 220 plus 12, 352. So the R total is equals, and then we're going to use V, we're going to use the VR, but we're going to look for I, so VR, so that would be 6 over 352. So now calculate quickly. 6 over 352 SD. Okay, so that equals 0.01705 amps. And that was number 4 completed. Okay, now we're gonna calculate the current. That would flow through the resistors if they're connected series using Ohm's law. So first of all, we're gonna use what we got on our last answer, the resistors. So B 220 equals 0.01705 times 220 V 12 equals 0.01705 times 12, and then for V120 equals 0.01705 times 120. Okay, so now we're gonna put these in a calculator. Okay, so now 1 second, we'll put this in the calculator. 0.01705 times 220 equals 1 second. 1 sec. So that was 3.9. Okay, so that would 3.7499 volts. I'll change this to 120, then SD 2.0454 volts, and then also change it to 12 0.20454 volts, and that is how to calculate the current flowing through the resistor if they're connected in series using Ohm's law. Okay, so next I'm going to be demonstrating the coarse and fine-tuned voltage. So for number 7, demonstrate the coarse and fine-tuned voltage control of DC supply and set the voltage chosen in step 4. So obviously I chose a volt of 6, so to tune it, you can coarse it to
This is the second one.
6. Obviously, I want to fine tune it here a tiny bit. So I get this on 6 on the dot. And this is the amount of amps you can put in it. You really don't want to put on like too crazy. You can put all the way to 1 bar and blow up your resistor, so like that. And you can also set a limit here. How much amps? Set a limit. So next of all, we're going to connect the DC supply across the circuit, which uses the series for number 9. Also, I've already pre-done it, so I'll see the wires here, multimeter, and then like this. These are all connecting. These are already all connected to make a circuit. These are already a circuit, but I connected all the wires just to make sure. The negative wire needs to go here. This node, negative wire needs to go here. And here. The 2 positive needs to go on this line here. So now we're going to show that the current is flowing through the bench supply displayed for half bar press. So I'll say on this quick. And before, amps was 0.1 sec. So on 0.16. If I convert those to milliamps, it would be 0.07. But obviously I didn't convert it there because it would be 0.7. So their current, current is flowing through the bench supply. If I press the on off button, that's for number 10. Yeah. So next we're going to be measuring the voltage across each resistor using the lab multimeter. So I've already pre-put the wires in for thing. So I'm just gonna see it on this, and they get 123, and we're measuring brown, red, brown. So I'm measuring this. That's 123, so a bit more ohms. So that's it done there for brown, red, brown. And then for brown, red, black, obviously is 12 ohms. Here's 11.94. Now the last one, red, brown. The wires like this. And I got 129.76. Already pre-made it, so 129.76. Was a bit thing, but yeah, that's quite. Was that one. So yeah, that was measured. So I just take this off using the multimeter. So for the last one, I'm going to show the effect of setting the current limit half the expected current. Calculate, okay? So I'll set the limit to 6 volts, and the answer I got was 17 milliamps. So half of that I'll just on this quick. I need to set the amps to like 8. So as that goes down, so does the voltage, it drops. a sec. The voltage needs to drop so the voltage will go down. Correct. And then wait. As soon as the amps go down, so does the volts. As a safety option. If it can go down. Okay. As soon as the amps go down, so does the volts. So we can cut in half. And that'll be for number 12. That's everything done.